getting to the basics here. What is Six Sigma? And I'm, as I said, not going to assume anything in terms of basic level. I'm presuming there are people who are novice, totally new to this, and that's where we're going to start. The first, thought that comes to our mind when we hear the word Six Sigma is undoubtedly that it's a metric, right? A six one number, and sigma, of course, is the statistical kind of formula and or symbol. So that's the first image that comes to our mind. So rightly so, Six Sigma is has a connotation of a metric, and we'll talk about it briefly. Why do we need a new metric to measure our process defects other than the ones that we already use? The second connotation to Six Sigma is that it is a process improvement methodology. And some of you who may be familiar with the DMAC approach, so this is integral part of Six Sigma. That's another perspective that we carry with Six Sigma, and that's what we're going to talk about also briefly today, how it can be used as a process improvement methodology in all the organizations and industries, and it's really a helpful methodology. And the third aspect, which is associated with Six Sigma, is that it's kind of a whole system. If you ask people from GE or Motorola, people who kind of started this, they'll say this is a way of life. Six Sigma is a way of life. It's not a tool, it's not a metric, it's not a methodology. It's much, much larger than that. So these are different connotations that we associate Six Sigma with, and we'll try to uncover some of these today as we move along. So I'm going to start with the first association. When we say Six Sigma, we say it's a metric, and as I said, the symbol that comes to our mind is the standard deviation. For those who are new to this term, just remember this as a metric to measure defects. So it's again just a quick note here: 18th letter in the Greek alphabet, and essentially it's a metric to measure the effectiveness of any process. Now, why on earth do we need a new metric? We already have metrics like percentage or an average or other things that we can simply use. So, in order to bring Six Sigma into the context, why do we need Six Sigma? I'm going to relate it to the coronavirus, which is the current hot topic, of course, of concern for everyone. So there may be viruses which may be, I'm just saying, visible to naked eye, but we know corona is something which is like 100th or maybe 1000th width of a human hair. Now, when we come across something which is not visible through naked eye, we for sure know we can never see it through naked eye. So we need to modify our way of seeing the virus. It is definitely not visible through naked eye, so we need to fine tune our way of looking at it through a microscope or a lens or whatever be the case. I think the same analogy works when it comes to Six Sigma. So on at one level, we may be measuring the processes in terms of percentage. We can say that we are at 90% accuracy or 99% accuracy, which in most scenarios looks great. But we will see shortly why the percentage may not be the best measure to look at a process. So if traditionally we say that we measure our processes or defects by percentage, and we say that a process is at 99.9% quality, we say it's great, man. What else we need? I mean, if our processes within our organizations are at working at 99.9% quality, we would be on seventh heaven. However, what you're going to see next is what really this means in terms of numbers. When I say 99.9% quality, it could mean 20,000 wrong drug prescriptions per year, and you would know what would happen if a person who is ill is given a wrong drug, right? It could be terminal for all we know. So it can be dangerous. 99.9% quality also could mean unsafe drinking water for almost 1 hour each month, maybe from the filter that we use or whatever RO system that we have, and that can be hazardous as well. So now the whole approach to the percentage is changing. We assume that 99% or 99.9% is great, but looking at these processes, we need to revisit the definition of how we want to measure accuracy. There are some more examples just to elaborate on this one. No telephone service or television transmission nearly 10 minutes each week. That would still be 99.9%, but I'm not sure how many of us will be happy seeing that. Two short or long landings at an international airport each day, which could mean, a blunder or an accident. So I'm sure nobody would accept that. So looking at these examples, 25,000 lost or incorrectly delivered articles of mail per hour. Imagine people getting wrong mails or not getting the mails or whatever be the case. Over 9,000 wrong serious crime convictions per year. So all of these numbers that you see on your screen is equivalent to 99.9% quality. But the organizations who are behind this, they are not happy with these numbers. They want a more finer metric to really measure their processes, and that's where the concept of Six Sigma comes in. So we introduce another metric which will measure the processes at a much higher level of accuracy so that we can really see what's going on. So if I want to really compare these percentages with a Six Sigma metric, so as you see here, the first column that you see is the percentage accuracy, um, and the DPMO stands for defects per million opportunities. Defects per million opportunities, which means a million times that an error can happen, how many times did it actually happen? And on the right, extreme right column, you see the sigma level. And as you can see that it is much more sensitive indicator than percentage. So it's that microscope from which we can see nearly 100 width of human ear thickness. So that's the measure. That's why the measure was introduced in the first place, so that we can look at these processes at a much finer level of detail. Now if you notice here that if I were to move from a 3 to a 4 sigma process, just one sigma jump, I would need to improve my processes almost 11 times. If you notice, next to 3 sigma we have 66,000 defects, and next to 4 sigma we have around 6,000. So almost 11 times improvement needs to be made for a process to jump from 3 to 4 sigma. And if you look at 4 to 5 sigma, just compare that, you will see that you need 26 times improvement to go from 4 to 5 sigma. So the journey becomes more and more difficult as we go higher up the sigma level. And I'm just doing the maths here. I'm just dividing 4 sigma equivalent DPMO, which is 6210, divided by 5 sigma DPMO, which is 233, and that comes out to be roughly 26 times. And if you do the same maths with 5 to 6 sigma, so if you want to improve your processes from 5 to 6 sigma, you need to improve your processes 69 times. So it really becomes our kind of measure where we fine tune our processes, we improve our processes so much that it really, kind of becomes world class. And that's where the whole concept of Six Sigma originated, especially for the airline industry and other industries where we could not afford a single error. I think that's where the concept of Six Sigma originated. Just to elaborate further of the difference between Six Sigma levels from a more layman perspective, as I said, the higher we go at the Sigma levels for a process, the more difficult it becomes. So if I were to equate one Sigma to the number of misspelled words in a book, it would be equivalent to 170 misspelled words per page in a book. If I were to look at 2 sigma, it would mean 25 misspelled words per page in a book. Better, good. 3 sigma would mean only 1.5 misspelled words per page in a book. So now the measure is becoming tougher. As we graduate to 4 sigma, one misspelled word per 30 pages in a book. So now we are really talking quality here. It's really error proofing and getting into the place where there's no scope of any mistakes. As we go further up, 5 sigma, it's one misspelled word in a set of encyclopedias. So the measure becomes more and more tough. And ultimately, when we come to 6 sigma, we say one misspelled word in all the books in a small library. So this is just a layman perspective of what sigma levels would mean when we work through the improvement process. So I think just summarizing what we have discussed till now, we are saying that sigma is a more fine-tuned, a finer measure of measuring the accuracy of your processes, uh, much more finer than the percentage, where we really cannot make out whether it's good for our processes or not. So now we will shift gears and we'll move to the next connotation of Six Sigma, as we discussed in the initial slide. We said Six Sigma is known as a metric. We have talked about it. We'll spend some time now in talking about the Six Sigma process improvement methodology. And for those who are already familiar with this, it's called DMAC as an acronym. D stands for define, M for measure, A analyze, I improve, and C control. Now, this is the methodology that can be deployed across organizations, across industries, and it has great tools, simple tools, which can be learned by everyone, one and all, and deployed in their own departments to bring about improvements. So we don't really need advanced statistics, as maybe the thought in our mind when we think about Six Sigma. The first thing comes to our mind is it's very statistically driven. It is stuff like that, but it has this side uh, of improvement methodology where most of the tools, I would say around 50-60% of the tools are simple for everyone to deploy, and it also is helpful in bringing about improvements, in 60% of the cases, I would say. For the 30%, you really need advanced statistical tools, which probably need a black belt in Six Sigma terminology, and probably another 10% could be at a very high advanced statistical level. But I'm saying 60% improvements within every organization can be addressed through this process improvement methodology and use of simple tools. And that's what I would like to spend some time today in kind of simplifying this DMAC approach for our our audience here, especially those who are not too familiar with this framework or who are new to quality. So I'm going to go ahead now and get into each of these phases briefly. And as we run through these phases, we will also look at some of the quality control tools, how we can use them effectively, and how it can make our life easy, in terms of all the functions and all the departments, they can use these simple tools and techniques. So that's what we're going to talk about now. So as the name suggests, the first step is define stage, where we define the problem that we are trying to address. So remember, this is a process improvement methodology, and there is a saying that well begun is half done. So if we are able to define the problem well, it really takes a lot of challenges away, that we might encounter later on. And I have been conducting sessions or on these in various organizations through the years, and I've found that hardly 20% of the projects are really defined well to be able to really identify or pinpoint what the problem is. And that's a great opportunity for everybody to spend some time on it. And that's where Six Sigma rigor comes in. A lot of tools in this define phase helps us to understand the problem and make sure that we don't make many mistakes while starting the project, so that we don't end up on the wrong foot later on. So when we talk about problem statement, essentially is a statement that describes in specific concrete terms what the issue is. Now, many times we might say that we are encountering defects in the assembly area. I'm just picking up a random example from a manufacturing organization. Now, that's a very vague problem statement. It has to be specific. We'll see how we can make that specific. So it needs to describe the present undesirable situation. So we said, yes, there are defects in the assembly area. It needs to summarize the problem with clarity and objectivity. So there has to be some ballpark figure, some number. So we say that the number of defects have increased. Let's say they have doubled in the last 3 months. So maybe some objectivity bring into the problem statement. Helps to convey the specific problems to others. Of course, that's going to be helpful. Now, that's one aspect which I really, kind of enjoy in Six Sigma framework. The tools are not only used to really understand the problem, but they're also used to involve people or different stakeholders within the organization. So I think that's the essence of Six Sigma. It helps us to kind of make sure that all the key stakeholders are involved at the right time, and we progress smoothly on the projects. When is it used? It is used, of course, as I said, to gain a common understanding, clearly explain the problem to others, and we try to be as specific and quantifiable if possible. If we have some data, we can say that we have been encountering, let's say, 15% defects in the last 1 month as compared to earlier. So they've improved, they've increased. So something like that. So we can have some objectivity to the problem statement. At this time, we don't jump to conclusion. Usually people would say that the defects are due to, let's say, the incorrect raw material from the vendor. But that's like that's a jumping to conclusion or jumping to a solution. So unless until we really know what the specific root cause is, we don't jump to conclusion. We just identify the problem here in this phase. So we need to list down a problem statement and make sure we talk about what is wrong. So we say there are a high number of scratches or defects in the assembly area. Focus on the gap. So we say that the defects have increased by 15% in the last 1 month, right? So we could look at, or we are at 85% of the target or in terms of accuracy. So we need to understand what the gap is, where the target is, and how much we are at. It should be measurable. How often does it happen? How much and when? So we say that we have been observing a 15% increase in scratches in the assembly area for the month of October to December 2019, right? So we also add some timeline to that. Avoid broad and ambiguous statements, so we're trying to fine tune as much as possible. Positive, and focus on the pain, how people are impacted. So this is increased number of scratches are leading to increased rejection and warranty failure. So this is also, probably we can list down in the problem statement to know what is the impact of the problem here. So the guideline that is proposed in Six Sigma approach is that we answer how, what, where, when, who, but not why. That's something that we go as we go along in the initiative. So what the problem is, when did it occur? So we mentioned the time period, where in the assembly area, who's responsible. So as observed by Mr. X, who is the quality inspector, and as how do you know, it is reported in the quality inspection reports. So then it really sums up the problem statement slightly more accurately than what would have been. So this is just an example of how it helps us to really define what we are doing in terms of the improvement methodology uh, in a very systematic manner. Now, there are some other tools that we use in the Six Sigma define phase. Like, for example, we have the team charter, where we define the problem statement, we define the stakeholders, the team members, the timeline, the target. So all of that is defined. We have a problem statement that we talked about briefly. There are other tools like the brainstorming, consensus building, shared stakeholder analysis, SIPOC, that stands for supplier input, process output customer. So it's a way of mapping the process. And then we have the VOC, or the voice of the customer. So these are some of the tools that are typically used in the define phase of the Six Sigma project, and apart from others as well. As I said, the purpose of today's session is just to give a overview of the whole approach, and also to let people know that this is not something which is very complex. Everybody can use it, and if we try to use this rigor, it can help us define our problems better and be able to solve them more effectively. Okay, so on that note, we'll try to move to the next step, which is the measure phase. Now, the first stage, where we said we define the problem, define the charter, the team is ready, the targets are defined, timelines for the project is defined. Now, Six Sigma doesn't move an inch without data. And that's what we do in the measure phase, where we establish a baseline in terms of where we are currently, right? So that's what we do in the measure phase. We do data collection and try to plot the data in a meaningful way, so that it can be we can know where we are and where we need to go. So step two is about better understanding of the process and the magnitude of the problem. Now, in the first stage, we don't assume we have all the data, because we're just starting the project. So in this is the phase, the measure phase is where we really go about collecting the data if it's not already available, and understand the magnitude of the problem. The key activities, make a data collection plan. Now, this is again something that has a Six Sigma, has a rigor of bringing in on the table. We have to have a very clear data collection plan to make sure that once we start collecting the data, we don't have to go back to more data collection later on. So this tool helps us to plan all the aspects of data that we need to capture right at this stage. So this is a very critical step that many projects miss out on. And when they progress in the life cycle of the project, where we go to analyze phase and suddenly we find out, hey, we didn't capture this particular aspect of the data. So for example, if it is for the defects that we are talking about in the assembly area, probably we need to know, for the particular part, who is the supplier, what shift the product is getting made, who are the operators who have worked on that shift or on that particular part, what are the different, at what time was that part made, what was the specification of the raw material that was used. So these are the various kind of aspects that we might need in the analysis phase later on, and that's where we need to make sure we capture all this data right here. So this tool helps us to identify how to actually capture the right data, or what data to capture really, so that we don't go around in circles. Then record the results in meaningful way, and we'll talk about that. And of course, the outcome is having a confirmed problem statement and shared understanding of what's going on. So, of course, during the webinars or the sessions that we have, we do these activities where we ask people to really identify and what data we are going to track and all that. So now we are going to look at some tools that we use in the measure phase, where when we collect the data, how to present it meaningfully. And one of the popular tools that we use in the Six Sigma framework and in basic process improvement approach is the trend chart. And as many of you may be familiar, it's a line graph that connects the data points that represents the data that we are tracking, and it is tracked over a period of time to see what are the fluctuations in the data over a period of time. So on the x-axis, we plot the it's a time ordered data. It could be time of the day, it could be day of the week, Monday, Tuesday, Wednesday, it could be date, it could be month. So it's always time ordered data that's plotted on the x-axis, and on the y-axis you have the metric which you are measuring or trying to improve the process on. So this is a tool that we always use. I think this is a basic tool that is a simple way to analyze information, and this is again, as there's a saying that one picture is equivalent to 1,000 words. So similarly, 1,000 data points, if represented well in a picture, it really gives the whole perspective about how the process is doing, and that's what this trend chart does. So we have a step-by-step approach of how the trend chart is made. We have a timeline across the bottom. As I said, x-axis will be the time ordered data, and then we plot the data on the y-axis and connect the dots. So this is an example that we typically do in a training, or probably subsequent webinars that we'll be doing. We'll be actually doing some actual examples using Excel and other applications, and have the participants really draw this. So this is just an example of the trend chart that is for a CSAT for a particular program, plotted for time period Jan to December. As you see on the x-axis, you have time ordered data, right? And on the y-axis, we have the CSAT percentage, the customer satisfaction, which is being plotted here. Now I'll just stay on this slide for a few seconds and let you interpret 5 inferences from this trend chart. There are 5 interpretations using this trend chart. If you look at this trend chart, you'll be able to see something or gauge something about the process, and I'll just give you a few seconds to reflect upon that, and then we'll discuss it. Five interpretations about the data that we are representing here. All right. So if you had the time to think through that, if you see the first one is very obvious that in the month of September, something drastically different happened, and the line shows that it dipped beyond the normal range of the data. So that's one interpretation. The second interpretation could be that the range of data, leaving alone the the September data, is ranging from almost 76 to 85. So that's the range. So around 9 percentage points is the range in which the data fluctuates. The maximum is 85%, the minimum is 76%, leaving alone the 62.3, which is probably a special cause, which probably we have to look at separately. Then the other interpretation we can look at is 95% is the target line, so we are well below that, and we need to do something kind of drastically different, and that's what probably we need a DMAC project on this, where we improve the process and bring it closer to the target line. And the average is around 80%, and that's what the green line that you see here. So these are like the 5 interpretations that we could quickly make out regarding the process, the data, that probably you would not have been able to make using this, the data that you see on the screen. Uh, okay. So I am moving my screen, but I'm not sure if everybody is able to see the movement on their screen. So I'll just no. Okay. So what's wrong here?
Aman, if you could just stop sharing and start sharing again, I mean, that will
Okay.
help.
Okay. Okay. Okay.
Yep, it has moved to the next slide.
Yeah. 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 All right, great. So what I was saying is that if I look at this data on this on the screen now, I really can't figure out much in that. But if we really represent it in a trend chart, we were able to easily figure out like 5 interpretations about the process. So it really tells you about the program health at a glance, and that's the strength of this tool. Now, again, it's a simple tool. Everybody can use this for their processes, irrespective of their departments, irrespective of whether they have the quality background or not. And that's what I think we wanted to really convey through this webinar today, that quality tools are not really difficult. They are easy for everybody to interpret and understand. And I would say 60% of the issues we could address using these simple tools. Now, one interpretation that was very obvious in the previous slide was that September data is really way off, and there's something drastically different that happened, and that's a good question to ask. What really happened in September where the CSAT was low using this trend chart? Now, apart from this, there are different other indicators as well, which can tell us that something different is happening in the process. So these are the things that we really go deep into the Six Sigma when we really go deep into Six Sigma framework. Now, for example, 6 points in a row continuously increasing or decreasing. So although they may not be looking at probably a very too much dip or a peak, but they still indicate that something different has happened in the process. So if we are a good kind of reader of these trend charts, and we know our processes well, we know the data is right, then we can, sitting at our desks, we can make out that something different is happening in our processes. And that's the power of these tools. The data can tell us, and we can take proactive actions meaningfully, ahead of time. So that's just an example of how we could use these trend charts more effectively in taking important business decisions even before the things go out of our hand. The second aspect, as you see here, is 14 points up and down. This also is cannot be random. It's a trend. Something is happening. The way we are capturing the data may be incorrect, or something is happening. There are two data points which are getting mixed up. So things like that. So then we start asking those right questions, and then we uncover some details. And all this can be done using the trend charts, just observing the data, plotting it accurately, and interpreting it, and asking the question when it should be asked. And the last two, as you see on this slide again, one or two, and this is what we already talked about, outside the limits. So something drastically different happened, or 8 points on the same side of the mean, that also indicates something different happening. So and if it is good, we can sustain it. If it is not good, we'll have to check what's happening and take corrective measures proactively. So I'll just I'm just pausing for a few seconds just for you to digest. Some of you who may be new to these. Uh, all I'm trying to share in today's session is that quality tools are not difficult. They are easy for everyone to understand, interpret, use it. Even if you don't want to deploy the entire Six Sigma framework, we can still pick up meaningful tools from these framework and use it for your processes, and it will help you to understand your process and improve as well. So now we move ahead to the next tool we have, which is called the Pareto chart, 80-20 rule, Pareto principle. 20% of the sources cause 80% of the problem. It's also called catch elephants, forget flies. So this is a prioritization tool where we identify the category of defects which need to be worked on first, and probably kind of prioritize, because we cannot work on everything together. So it's a relative importance of the problems and or possible causes, and we need to understand which one to work on first, where to concentrate our efforts on. And I'm just flipping through some of this. Again, as I said, we usually cover it in detailed sessions. Today is just an overview. And how we do it is we determine the categories of the various causes of the measurements that we want to use, tabulate it, and label them together. And this is just an example from a kind of a IT industry, where we say that why do customers call? So we have different reasons why they call: incorrect information, billing inquiry, connectivity. So there could be 50 such categories, right? So what we do is we sort them in descending order in terms of the number. So here we see the connectivity calls are maximum 40, and then followed by billing inquiry 25. Then we do a cumulative percentage of the total for each of the categories, and then we plot it in a chart. Now this is the Pareto chart, which tells us that we need to focus on connectivity and billing inquiry issues to kind of resolve our issues, and that will take care of, if you see the trend line here, almost 60% of our customers are calling because of connectivity and billing inquiry. So that means these are the two concerns that we can address, and if we are able to resolve the connectivity and the billing issues, ultimately these two bars will shift towards the bottom right section. That's the aim of the whole initiative, to make sure that the categories which are contributing more to the defects right now should be worked upon, and over a period of time we are able to kind of move them towards the right they reduce in number, and then the incorrect information and installation, which are the next two categories, they become the top most concerns, and then we address them and so on and so forth. So it just helps us to prioritize where to work on. So that's what we do, magnitude and the largest bar, we talked about it. So we can, of course, have many examples of that. This is another kind of example of a Pareto chart. So what we discussed, there are different tools. As I said, the data collection plan, where we decide what data to collect. We have the trend chart, we talked about it, with Pareto chart, we have the histogram, process map. There's so many tools which are useful, simple, which everybody can use, even laymen can use, and improve their processes. Uh, and that's what we cover in the measure phase. So what I'm going to do is probably kind of run through the rest of slides slightly quicker, because I know we're just 10 minutes on the top of the hour, and another 3 steps to go, and plus some other things that we want to talk about. So the third step for the DMAC is the analyze phase. Now we have the data, we have the problem statement, we have the data, we have uh, put it meaningfully in the terms of trend chart and the Pareto, and now we need to analyze and go to the root causes of the issue, and that's what are the various activities that are done during this phase, where we try to go deep into the process, and we'll look at some of the tools that we use here. One critical tool is cause and effect diagram. It's also called fishbone or Ishikawa diagram, which again, a lot of emphasis in Six Sigma is laid on visual display of information, pictorial representation. So it helps everyone to appreciate the problem meaningfully. So this is something that help. This is a tool to involve everybody, or involve the key stakeholders, and think through the solution. So I'm just going to quickly share the steps here. So on the right side of the board or whiteboard, wherever you are doing this activity, you need to write down the problem, which is, say, effect, which is CSAT is too low in this case, let's say, and we need to brainstorm on what could be the possible causes for that. So we involve all the stakeholders, they brainstorm, they identify what could be the possible reasons, and then we try to uh, affectionize them together in categories, group them in similar ideas. Uh, 7M stands for money, method, machine, material, measurement, morale, so men. So these are the 7 M's. So we can categorize all those ideas in these categories, and then continue drilling down deep into each of these categories, so that we can come to the root cause of the problem. And that's where the 5 why analysis also comes handy, right? So for each of the issues, we keep on asking questions and drill down deeper till we come to the root cause of the problem. So I'm just flipping through to the output slide here, just so that we we are able to cover the whole thing quickly. So this is the output of the fishbone diagram. So we have different aspects that led to low CSAT. It could be process-related issue, it could be people, it could be technology, environment, and then we keep on diving deeper into the various aspects. I have examples of from the manufacturing, where we say the defects were high due to probably multiple shifts, or probably incorrect training of the operators. And there's one point which I may quickly want to highlight here, is something called as might cause check. So when you list down the various issues here, you need to make sure that you link the issue with the effect, or cause with the effect, with a might cause check, which means that, let's say we say poorly trained operators might cause defect. So it makes sense, right? Or untrained, lack of training might cause defect, or multiple shifts might cause defect. So you need to link the possible causes with the effect using the might cause check. So all these aspects are explained in great detail in the Six Sigma rigor, and which helps us to use these tools effectively and get the best out of them. So I'm going to this is again from a IT industry where we have a sorry high HT, the average handle time, and it could be because of high hold times or it could be talk time, various aspects. So it is used across industries, and it's very effective tool to engage everybody and get to the root cause. So I think we're just going to flip through these couple of slides here, and there are a lot of tools, as I said, already part of the Six Sigma framework. Simple tools we have talked about Ishikawa today or the fishbone. There's a value and non-value added analysis. There's scatter plot, which establish a correlation between two factors, and the 5i analysis, and many others as well. So all these tools help us to really solve the problems that we are addressing. Quickly moving on to the improve phase, where we develop a solution. Now this is the place where we do action planning uh, and really implement the solutions to the root cause that we have identified in the previous step. So again, I'm not going to spend too much time on this. We are going to flip through that. Action plan is the critical template here, where we identify who is going to do what, when, and we try to follow it up. And during the improve phase, we also have a before after picture. We already discussed the Pareto earlier. Now after the improve phase, once we have done the action planning, we figure out that the category which was highest earlier now has come down. So that means the impact of that defect has reduced, which was the aim of the improvement. So which means that we were on the right track, we've got the right solutions in place, right action plans in place. And this is another example, the line chart that we saw earlier. Now it's showing continuous improving trend. And last, as we saw, 6 points continuously upward or downward indicate a positive or negative trend. So in this case, the CSAT is improving. So we can be rest assured that whatever actions we have done are in fact effective. So these are some of the tools that we use, and many of them are already used in multiple steps as we looked at. So next and the final section here is the control phase, where we whatever we have done, good job we have done, we kind of hold the gains. We establish standard operating procedures, we document the process, we do the trainings, we celebrate. So all this really are things that make sure that whatever we have improved, uh, check sheets are used to track the improvements. And as you see here, the work instructions, the standard operating procedures, audits, process mapping, documentation, all of that is done to make sure that we don't uh, revert back to the original phase. So I think this is just I know it was real quick high level view, but I think the purpose is to share that it's not rocket science. It's simple. Many tools are really simple, and they can help us improve our basic processes. Uh, just final couple of slides here. When we talked about Six Sigma initially, we said it's a metric, it's also a process improvement methodology, plus it's a system as well. So when you talk about system and organizations which deploy Six Sigma as a system, they have a whole set of teams who are master black belts, green belts. You must be familiar with this terminology, and that's how the entire organization gets engaged in the Six Sigma framework. So I think the last two slides, and then it will be back to Rahul for kind of taking up a few questions if we have time, and then winding up. So once we're going to schedule the upcoming sessions, the webinar, hopefully on similar topics. It could be Six Sigma problem solving. I would say that they are more applicable for all the department owners, the function owners who are responsible for process improvements. Anybody who wants to improve their processes, they'll be finding these webinars useful, because as I said, we'll be using simple tools and techniques that you can deploy irrespective of your industry or function. The project managers, of course, as I said, it's a project improvement methodology. So it's a great help to increase the rigor of your project management. Process owners who want to learn basics of statistical tools, I would encourage all departments, HR, sales and marketing, planning, everybody to kind of be familiar with these simple tools so that they can use their data meaningfully in their own departments and look at the data and take intelligent business decisions. Quality champions, of course, all the quality experts that we already have in the call. I'm sure there'll be some learning from different frameworks that we can incorporate. Even if you're not following Six Sigma, you may be following any other standard for automobile. It could be IATF, it could be COPC for the IT industry, but you can still benefit a lot from these framework and incorporate in your already existing framework. And of course, those aspiring or thinking that, hey, should I go for green belt or yellow belt, this will give you a flavor of what you are heading for and why you should attend the webinar upcoming series that we're going to schedule, hopefully, because obviously this is going to be a new normal. As Rahul suggested earlier in the call, we must use this time to upgrade our skills, help revisit your quality initiative from a fresh perspective. The reason why everybody joined today is, I'm sure they are happy, they're doing well with the quality initiative, but they know that it's a continuous improvement process, and there's something we can always add and fine tune and learn, and that's where this is going to help. Get to know the best practices from various organizations and industries. As I know, we have different industries join in today. As I said, pharmaceutical, software, manufacturing. So I'm sure we will learn from each other as well. And human aspect of driving change. So we're not only going to talk about the tools only, but how to deploy them, what challenges you might face in your organizations, how to overcome them. So we also talk about the human aspect of driving change. And of course, it's a ready toolkit, as you see, a lot